Hi guys, it's been a while since our last video in collaboration with André. During the past months, we were very busy with other projects and experiences. Among other things, we have been contacted by NextMind. They've asked us to test their brain-computer interface, and we have decided to build a project over it. Today, we are going to see how to become a real wizard on Unity. NextMind is a French startup that's working on a brain-computer interface. They have sent us their dev kit to review and test it from our point of view as developers. This device is supposed to allow you to control your PC using your mind.
You're a wizard, Harry.
Their app comes with some demos and also the Unity SDK. After a calibration phase, it is able to recognize some particular tags when you focus on them. We have started familiarizing ourselves with the device, playing the demos, and reading the documentation. After that, we have focused on the design of the experience. Our feeling using it was that everything was pretty magical, so we have decided to create a sort of magic academy. The player should have used the NextMind sensor to choose which spell cast. But to be a real wizard, a player can't use a mouse or a keyboard. So why don't do everything in VR using the Oculus hand tracking? We had already experienced the hand tracking by Oculus, so I won't bother you with the setup and I'm gonna leave you the video where we go deeper on that topic. The NextMind SDK comes with some examples and all the tools necessary to create your own experiences. The system uses particular elements called the Neuro tag. They are components able to make an object interactable using your mind. When a tag is recognized, it can trigger an event. In our case, we're gonna use this event to spawn the selected spell. By default, their appearance is sci-fi-ish, so we have customized them a bit, making them more fantasy-like. We have kept tags as clean as possible, avoiding problems with the recognition. Once a spell is selected, we calculate its velocity according to the end movement. Since no buttons or controller were involved, we have needed something else to throw the spell. We have placed a collider in front of the player, and when the hand touches it, the spell is released. The direction was calculated using the head and the hand positions. The strength, instead, was modulated by the magnitude of the velocity. Searching for some inspiration about the environment, we've found this handsome asset on Sketchfab. We have imported it in Blender and we have created a large hole for our wizard training starting from that. For the shading, an old friend has come to the rescue. We've used the Zelda Toon shader we've created for our first video. But a self-respecting training camp needs some dummies. Back in Blender, we have created the model and its rig. Using the animation rigging package, we have settled up the effector that makes our dummy moves accordingly. So we've recorded an animation that shakes it with a bit of damping. With the environment completed, it was the spell's turn. We've created one VFX graph per spell, making them different and detailed. But those spells didn't reflect the style of the environment. So we've redesigned all the VFX to achieve a more cartoonish style that could match the wizard school and the dummies. We've drawn some textures, made some shaders and put everything together using the VFX graph. Each spell is composed of several elements. For instance, some particles use alpha blending to compose the color, others use the additive to enhance the glows. Also, for some particular elements like the orbs, we have used the shader graph that is compatible with the VFX graph, enabling the experimental nodes. When a spell hits something, it is supposed to do a sort of damage. To highlight the hit against the environment or dummies, we've worked on decals. Initially, we've used the output particle forward decal provided by the VFX graph, but they had some troubles with the VR setup. So we had to find a solution. We've read about the decals that would become available for URP in the last Unity beta, and we've decided to give them a chance. Using the decals, we have found a problem with the edges. When a face is parallel to the projection direction, the texture looks stretched. To solve this, we have enabled the angle fade property in the shader. This property allows you to set up the fade of the decal based on its angle. In addition, we've added a fade property to vanish the decal over time. Eventually, we've added a new VFX to each impact using the same textures we have created for the spells, making every hit more dramatic. Wrapping everything up, this is the final result. Let us know in a comment below what you think about this project. Don't forget to subscribe, smash the like button and follow us on the other socials. See you next time. Cheers!